Hello MPC first year students of IGNOU. Welcome to my channel Samvedna Psyche. Today I will be sharing solved assignment for Statistics in Psychology MPC 006 for the July 2023 and January 2024 batches. Whether you are just starting or already deep into your studies, these solutions will help you navigate through your assignments with ease. So let's dive in. As always, before writing the assignment solution, include the title page and the question paper, and also mention the subject along with subject code, tutor marked assignment, course code, and assignment code. Let's start with section A. Question 1. Describe the assumptions, advantages, and disadvantages of non-parametric statistics. Before you start writing, remember to leave a left margin of 3 to 4 centimeters, and after every answer, leave a space of 3 to 5 lines. Include diagrams wherever necessary. Non-parametric statistics can be used when the assumptions of parametric methods cannot be met, and the main assumptions of non-parametric are: it is suitable for sample sizes which are small, it is well suited for the data distribution which is not normal or skewed, it is well suited for analyzing data which is measured on nominal or ordinal scale, and it is applicable in situations where the population distribution is not known or cannot be assumed to be normal. These are suitable for analyzing categorical or classificatory data. And lastly, they can be applied to data which is obtained through non-random sampling methods. Next, advantages of non-parametric statistics: flexibility in data requirement, ease of application, objective assessment, availability of critical values, and applicability to random samples. Disadvantages: it is wasteful in ideal conditions. Ideal conditions are the conditions where we can use parametric test. Lack of quantitative precision, information loss, dependency on software, and lastly, reduced statistical power. Question 2. Explain the concept of normal distribution. Explain divergence from normality. Normal distribution is also referred as Gaussian distribution or bell curve, and its main characteristics are: it is symmetrical around its mean. When depicted graphically, it appears to be a smooth bell-shaped curve. In normal distribution, the mean, median, and mode all coincide at the center, which is the point of highest data concentration. And mean, median, and mode are the measures of central tendency. The spread of data around the mean is explained in terms of standard deviation. And lastly, the normal distribution is defined by a probability density function which describes the likelihood of observing specific values within the distribution. Second part of the answer, divergence from normality. Divergence from normality can be seen easily in the shape of the curve. And divergence is of two types. First is skewness. Skewness measures the asymmetry of the distribution, which helps us to find out the shape and the direction of the data. Skewness is of two types: negative skewness and positive skewness. Negative skewness is seen when the tail extends towards the lower end of the scale or the left side of the mean, while positive skewness is seen when the tail extends towards the right side or the higher scale. Second type of divergence is kurtosis, which focuses on the peakness or flatness of the distribution curve as compared to the normal curve. Kurtosis is of two types: platykurtosis and leptokurtosis. Leptokurtosis is when the peak of the curve is sharper than the normal curve, and platykurtosis when the peak is flatter than the normal curve. And then with this you'll conclude your answer. Question 3. The scores obtained by early, middle and late adolescents on adjustment scale are given below. Compute ANOVA for the same. This is a definite question for your exam. It's a 10 marker in the exam in section A, and along with this you will get minimum 2 more numericals, that is 6 markers in section B. But recently they have started giving 3 questions in section B. So that way you will get 3 6 markers. That means 18 marks in section B and 10 marks in section A. So this way you can score easily 28 with only numericals. So the data is provided. First of all, we will assume that early adolescent is equal to x1, middle to x2 and late adolescent as x3. And we will copy this data in tabular form. I have used 2 different colors to make it easier for you to understand and differentiate also. With yellow one, I have used the data which is provided. X1, X2, X3 is the data which is provided to us. So this data is copied as such. And then we take out the sum of this column, that is sum of total number of observations here. So you will add up all and you will get sigma x1, which is 29. Similarly, you will do it for x2 as well as for x3. Now the next column to it is, as you can see, it is x1 square of this column, and this is x2 square and this is x3 square. So there is a slight typo. Instead of x1 at the base, it is printed 1, 2 and 3. So you can do the correction here. Now you will take the square of this column, that is x1 here, square of 2, square of 3 and so on. Similarly, take the square of x2 and write it down here as x2 square, and square of x3 write down in the third green column as x3 square. Then what you have to do next is you have to add row wise the data of each x1, x2 and x3 column. That way it will be 2 plus 3 plus 7. That will become 12. Second data, 3 plus 2, 5, 5 plus 6, 11. So this is 11. So total x is representing the sum of x1, x2 and x3 row. So row wise you will do it for x. Then total x square, it will be the sum of x1 square, x2 square and x3 square. And you have to do the column total for each of the columns, as you can see here, like you have done for yellow one. Similarly, you will write sigma x1 square, sigma x2 square and sigma x3 square, as well as total x, sigma x is 100 and total x square, sigma x square is 382. Next is mean. Mean is equal to the sum of observation upon number of observation. Sum of observation we have already taken out here, which is 29. And number of observation, I have numbered them here. This column is added to show you that only. So there are 10 observations. So n becomes 10. N represents the number of observation. And for x1, we'll assume n as n1. For x2, it will be assumed as n2. And for x3, it will be assumed as n3. And all will be equal to 10. So we will take out the mean, sum of observation upon number of observation. Sum of observation is 29 here, number is 10. So the mean will be 2.9. Similarly, we'll take out for x2 and x3. So this is what you have to do. Now, the same thing we will use in the steps. It's very important to write the steps. Otherwise, you lose some marks. This I have already explained to you. N is equal to 10 and n is equal to n1, n2, n3. So all 3 of them are 10. And capital N is the total number of observation in all the 3 groups. We were given 3 groups, early, late and middle adolescent, which we have assumed as x1, x2 and x3. So each one is having 10 observation. So n1 plus n2 plus n3, that becomes capital N, that is equal to 30. So small n is number of observation in each group and capital N is total number of observation in all the group combined. Now step 1. Based on whatever we have done, we will start. Step 1, as you can see here, correction term represented as Cx, which is equal to sigma x whole square upon capital N. Sigma x whole square can also be written as this because x is equal to x1 plus x2 and x3. So sigma x1, x2 and x3 upon capital N can be written as n1 plus n2 plus n3. So you can write either this or this. Whatever you write, we have already calculated sigma. As you can see here in the table, this we have already calculated, sigma x. So we will put the value of sigma x here and value of n is 30. So after solving this, we get correction term as 333.33. Let's move on to step 2, sum of squares of total. Formula for this is sigma x square minus correction term. Correction term we have just calculated and sigma x square we have done above in the last green column. This one, this is your sigma x square. So you will use the value from here directly. 382 minus this correction term and you get your answer as 48.67. So SST is 48.67. Step 3, it is sum of squares among the groups, which we represented as SSA. SSA is equal to sigma x1 whole square upon n1 plus sigma x2 whole square upon n2 plus sigma x3 whole square upon n3 minus cx. We have got all the values above in the table. Remember that here you are taking sigma x1 whole square. So you have to take the value of x1. Don't write x1 square here. So if you see the table, this is your sigma x1, this is your sigma x2, and this is your sigma x3, 29, 30, and 40. So we have put that square of 29, square of 31, and square of 40, and minus your correction term, which is 333.33. So after solving this, we get SSA as 6.87. Step 4, sum of squares within the group. This is equal to SST minus SSA. SST we have calculated here. This is your SST and SSA we have calculated here. So we'll just put the values here and we get the answer as 41.8. SSW is equal to 41.8. Next we move to step 5, mean scores of squares among the groups. Here it is represented as MSSA, which is equal to SSA upon K minus 1. SSA we already know, we have solved it. Now what is K? K is the total number of groups. We were given 3 data, 3 groups. So K is the total number of groups. So here K will be 3. We will put the values of SSA and K here and we get MSSA as 3.434. Step 6, mean sum of squares within the groups. And the formula for this is SSW upon N minus K. SSW we have calculated here. This is your SSW. So we will put the value here. N is 30. We have seen above. Total number of observation in all the 3 groups, that is N. And K, just now we have done in the previous step. K is total number of groups. So that is 3. So after putting the values, we get MSSW equals to 1.548. And now your problem is almost solved. You only have to show the last step, that is calculation of F ratio. So you'll make the F ratio table, which represents the source variation among the groups and within the groups, sum of squares among the groups and within the groups. DF is degree of freedom, again among the group and within the groups. So to calculate among the groups degree of freedom, we calculated by K minus 1. And for within the group, it is N minus K. So we get the values here. For among the groups, it's 2 and within the groups is 27. Mean sum of squares, this we have calculated above. So you can show it here also. And similarly, mean sum of squares within the group, this also we have calculated above. And you will show it here. And then finally, you will divide MSS A by MSS W, that is mean sum of squares among the groups by mean sum of squares within the group, which are these two, 3.434 upon 1.548. And you get the F ratio as 2.218. Now, because in this question, they have not given you any critical value. So you don't need to go in detail, because with if you have critical value or if you have F table with you, then you compare this value with the critical value and then finally write your answer based on that. But here it is not there. So this degree of freedom is also used to see the F table. So because we are not seeing the F table, these are not used, but still you have to show it in the F table. So your answer is 2.218. Finally, you can mention in one line that F ratio is equal to 2.218. With this, we completed section A. Now let's move on to section B. Section B, question 4. Explain how the data can be organized using classification and tabulation. The data can be organized by different methods like classification, tabulation, graphical presentation, and diagrammatical presentation. But because we are asked only about two methods, so we will answer only those two. Classification helps in organizing the data into groups based on the similarity, and it aims to summarize the frequency of scores or score ranges for a variable, which is helpful in decision making. Types of frequency distribution is of two types, for ungrouped data and for the group data. Construction of frequency distribution, it depends upon the data range, which is determined by calculating the difference between the highest and the lowest scores. Number of class intervals should be between 5 to 30, or it depends on the characteristics of the data set. And the third one, limits of class interval. Class interval should have uniform width, and if the width is a whole number and conveniently divisible by 2, 3, 5, 10, and 20, that is always preferred. Then methods of describing class limits. There are three methods. Exclusive methods, where upper limit of one class becomes the lower limit of the next class. Inclusive methods, where the upper limit of one class does not become the lower limit of the next class. And third, true or actual class method, where class limit extends from 0.5 units below to 0.5 units above the face value of the score on a continuum. Types of frequency distribution, there are three types: relative frequency distribution, cumulative frequency distribution, and cumulative relative frequency distribution. Then second method, tabulation. Tabulation presents classified data in a tabular form, which improves readability and helps in analyzing the data statistically. Components of table. First of all, the table number is there, which helps in easier identification for reference. Title of the table, which describes what is there in the table. It tells about the content. Caption of the table, it's brief and self-explanatory heading for columns. Stub, these are self-explanatory and brief headings for rows. Body of the table contains numerical information, which is arranged according to the description of captions and stubs. Head note, it explains the unit of measurements which are used in the body of the tables. Footnote, it explains certain points related to the data in the table. And lastly, source of data, it mentions the source from which the data have been taken. Question 5, using Pearson's product, find correlation for the following data. So we are given the data here, two datas are there, data A and data B. So our first step is, we will arrange the data in tabular form and assume that data A is equal to X and data B is equal to Y. And as such, this data we will tabulate in the table below. So here, to differentiate between data A and data B, data A is equal to X, which I have shown in green, and data B is equal to Y, which I have shown with pink. So this we have copied as such from the table which is given along with the question. So after entering the data of X and Y, we sum up all the observation under these two columns separately. Total of X observations and total of Y observations. So if we add up all these, the sum comes to 360. So sigma X is equal to 360. Similarly, if we add up all the data here or observations here, we get sigma Y is equal to 155. Now in the next column, this green column, we are doing X minus X bar. This X bar means the mean of X. So before doing anything here, we have to take out the mean, which I have done here. You can see here, we have already got sigma X, and we know if you count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So total 10 observations are there. So n becomes 10. So mean is equal to sum of observations upon number of observation. Sum of observation is 360, number is 10. So we get the mean as 36. Similarly, we'll calculate mean for Y also. Y bar or mean of Y is equal to sum of observation, that is 155 upon n. N is 10. So it becomes 15.5. Now you can make the next two columns here, X minus X bar and Y minus Y bar. How we have to do? We have already got the value of X here. X bar or X mean we have calculated. So X minus X bar, 34 minus 36. 36 we have just calculated the mean. Similarly, 43 minus 36. So this way you will do for the whole data which is there in X. You will find out the difference between X and its mean. On similar lines, you will do for Y also. Y minus Y bar, this is the column. So here we will write Y first. First Y is 15. Mean we have calculated as 15.5, and then we will find out the difference and write it down. And this way you will do it for the whole data of Y. Now the next step is these column 3 and column 4, X minus X bar and Y minus Y bar. We have to take square of these. So here X minus, first X minus X bar is minus 2. So if you take the square of 2, it becomes 4. Square of 7, 49. So this way you have to square all X minus X bar and write in this. Similarly, you will find out the square of Y minus Y bar. This is your Y minus Y bar, first value. So its square is 0.25. Then 3.5 is the next one. Square of 3.5 is 12.25. In a similar way, you will take out for all the values of Y minus Y bar here and write them here under Y minus Y square. Then you will do the summation of X minus X square and write it here as sigma X minus X square, and do summation of this Y minus Y square and write it here as sigma Y minus Y square as the total. Then the last column, here we are showing the product of X minus X bar into Y minus Y bar. So to find out the product of these two, you have to multiply X minus X bar, that is column 3, by Y minus Y bar, that is column 4. So the values here are minus 2 and minus 0.5. So if you multiply 2 by 0.5, you get 1. If you multiply 7 by 3.5, you get 24.5. So this way you will multiply all the cells and write the answer here as the product of X minus X bar and Y minus Y bar. And then finally you will add up all these values and write here sigma X minus X bar into sigma Y minus Y bar, which is equal to 555. So you have done almost say 75%. Now the part which is left is what we have discussed here, what we are doing. We will write that in steps. So first of all, we have already done number of observation in each group. We have seen here and we counted them as 10. So it is 10. Step 2 is calculate the mean of column X and Y that we have calculated here in the first column and second column. So mean of X or Y is sum of observation upon total number of observation. So when we have calculated, it has come to 36 and 15.5. No need to show the working again because we have already shown in the table. Step 3, compute the deviation of each X score from its mean in column X minus X bar and deviation of score Y from its mean in column Y minus Y bar. This we have done already. Deviation of X from its mean and deviation of Y from its mean. So that we have already done in column 3 and 4. Step 4, compute the square of X minus X bar and Y minus Y bar under column X minus X bar square and Y minus Y bar square. This also we have done in column 5 and 6. This is the column where we have taken out X minus X bar square, and this is the column where we have done Y minus Y bar square. Then calculate the sum of each column X minus X bar square and Y minus Y bar square. We have calculated this also. This is the sum. Sigma X minus X square is 916 and sigma Y minus Y square is 360.5. And then step 6, compute the standard deviation of columns X minus X whole square or square and Y minus Y square by dividing each sum by n. So formula for standard deviation is Sx is equal to, we are representing it with Sx because we are doing it for column X. So Sx is equal to under root sigma X minus X bar square upon n. So square of X minus X bar we have already calculated. You can see it here, 916. So we will put the value under root 916 upon 10, and after solving this we get Sx as 9.57. Similarly, we'll do for Y minus Y bar square. Sy is equal to under root sigma Y minus Y square upon n. So the only difference here is instead of X minus X bar which we have used above, here we will, because we are doing for Y, we will use Y minus Y bar. Total we have done above 360.5. I have already shown you, divided by number of observation, that is 10, and we get Sy as 6. Now calculate the product of column X minus X bar and Y minus Y bar in last column and compute the sum of this column. This also we have done in the blue column here. This is the product of X minus X bar into Y minus Y bar, and we have calculated the sum also, which is equal to 555. So step 7 is also done already. Now final step, compute correlation using the formula. This is the formula for finding out the correlation. We have already got all the values now. The product of X minus X bar into Y minus Y bar, we have calculated in the blue column above, which is 555. N is equal to 10. We will put the value. Sx and Xy, we have just calculated in step 6. This is your Sx and this is your Xy. So 9.57 into 6. So after putting all the values, you get your correlation value of 0.966. Now after this, writing this last statement, it is very, very important. Otherwise, you will lose some marks. So you have to write as R is equal to 0.966. It shows a strong positive correlation between data A and data B. Now why we are calling it strong? It is strong because the value 0.966, it is very close to 1. And positive because it is having a positive sign. So this way we will conclude our answer. Question 6. Describe biserial and tetrachoric correlation with the help of suitable examples. Biserial and tetrachoric correlations both measure the association between variables, especially when one or both of the variables are dichotomous. First we'll take biserial correlation. Biserial correlation It measures the relationship between a continuous variable and a dichotomous variable that has an underlying continuous distribution. Then explain the example as I have explained here. I'm not going in detail of the theory part in this paper here as there are many numericals, so I prefer explaining the numericals. Calculation of biserial correlation, how it is done. You will write the formula. This is the formula given here, and then you'll explain what all these variables represent. Then tetrachoric correlation. It measures the relationship between two dichotomous variables that are believed to have underlying continuous distribution. Then you will give the example and formula. Formula for this is this. So you will mention the formula and then you will describe briefly what the variables which are used in the formula mean. Let's move on to question 7. Compute Mann Whitney U test for the following data. This is the easiest numerical in your stats paper. So the data is given, scores obtained on emotional intelligence scale by males and females. So the data is available. What we have to do is we will copy this data as such in tabular form. So here in this table, I have copied the data for the males as such, which is given, and here for the females as it is given. Then the next step is we do the ranking. After copying the data, first of all, we do the ranking, and ranking in Mann Whitney test is combined ranking. We do not rank males separately or females or two data separately. We do combined ranking for the whole data. And ranking is usually done in ascending order, that is starting from the lowest number. The lowest number will be given rank 1. So if you see the whole data, you will see 9 is the smallest one. So we will give it rank 1. Next is 10. So it will be given rank 2. Then rank 3 is given to 20 because that is the third highest. Rank 4 to 21. Now if we move for rank 5, we see 23, but there's another 23 here. So we cannot give 5 to 1 and 6 to another one. That will be wrong. So for this, what we do? We total the ranks. Now this type of data, when two or more than two data are having same value, such data is known as tied data. So we have got tied data here. So for tied data, how the ranking is done is the next after 4, the next ranking was 5 and 6. Now if we take 1 as 5, 1 as 6, it will be wrong. So what we do is we combine 5 and 6. That is sum of 5 and 6, that is 11. And the number of data which is tied is 2. So we divide it by 2. That makes it 11 by 2. That becomes 5.5. So we give similar ranking to both of them, 5.5 to this as well as to this one. So this way we provide ranking for tied data. Now we have already given ranking 5 and 6. Although we have not given it as 5 and 6, but we have calculated for 5th and 6th position. So now the next ranking will be 7. So 7 we give to this one 25. And this way you will proceed with the remaining data and give rank to all the 20 observations. Ranking for males we are representing as R1 and ranking for females we are representing as R2. After giving the ranking, once it's done, we find out sigma R1 square, that is sum of all this column. That is sum of all the observation under R1 and sum of all the observation under R2 separately. So sigma R1 is equal to 119 and sigma R2 is equal to 91. Now next step is find the sum of ranks for males and females and separately that we have done. Calculate U using the formula. This is your final step. So formula for calculating U or Mann Whitney value is this. So if you see the formula, we are taking out U as well as U dash. And the difference is in U, it's N into N into N1 into N2 plus N1 into N1 plus 1 by 2 minus sigma R1. And the only difference in U dash is this. Instead of N1, N1 here, we take N2. And instead of sigma R1, we take sigma R2. So we have got all the values. There are 10 ranks. If you count, we have given the ranking till 20. So if ranking is till 20, it means each group is having 10 data. So n is equal to 10. We will put the value. R1 and R2 we have calculated. So you will put R1 here and calculate U, and here you'll put R2 and calculate U dash. Now you have to see out of these two, U36 and U64, U dash 64, which one is smaller. Obviously U36 is smaller. So that will become your answer. So step 4, identify the smaller value between U and U dash. The smaller value is U, that is 36 is your answer. Question 8, compute chi-square for the following data. So the data is given. It's work motivation for managers, junior managers and senior managers, and work motivation whether it's high or low. So the data is provided here. So the first step will be, we will add one more column to this data and prepare the observed value table. This is the observed value table where we have copied the data as such. Only this last column, this column we have added, and here this last row we have added. So these two additions we have done in this. And here we will do the row total and write here. So row total of for the first row is 22 and for the second row is 34. And then we do column total. For column high, it's 22, column low is 34. Now we have got the observed value table. Step 2 is compute the expected value for each cell by multiplying the sum of row by the sum of column and then dividing by the total sum. So that is RT row total into column total upon overall total of rows and columns. So for this we will prepare expected value table, which is similar to this only. The only thing is we have to calculate expected value here. So I have used E10 to show that it is for this table 10. E12 to represent that it is for this table to differentiate between the cells. So we will calculate these. E10 is equal to row total. Row total for this row is 22 and column total for this column is 22. So 22 into 22 and overall total is 56. And you get the value for E10 as 8.642. Similarly, you will do for the remaining 3 also. And this way we get the expected value. Now we have observed value and expected value. So we will tabulate these two together. Step 4 is that only tabulate all the observed value and expected values and find out the deviation between the observed and expected values. So first we have tabulated observed value, expected value, and find out the difference between observed and expected value. Observed value minus expected value. Then your step 5, calculate the chi-square value for each cell individually in column 4. This is your column 4. So here we are calculating chi-square for each cell. Each cell means for this row, we will do it in this cell. Then for this row, we will do in this cell and so on. So here O minus E whole square upon E. O minus E we have calculated here. Put the value here. And expected value of E is equal to what we have calculated. This one. This is E. So put the value, calculate it, and you get the answer as 0.213. Then for the next one, again, here you will put the value O minus E, which is calculated in the previous column, upon expected value, which is 13.357, and you get the answer as 0.37. Follow the same procedure for the next two rows also. And this way we take out O minus E whole square upon E. for each observed and expected value. And if you see in the formula, I have given the formula for chi-square here. It's equal to sigma O minus E whole square upon E. So we have not written here sigma because these are the individual totals of each value or each row. But when we add them up together, which comes to 0.576, this becomes sigma O minus E whole square upon E, that is equivalent to your chi-square. So your answer is chi-square is equal to 0.576. Next, section C. Question 9. Measures of central tendency. Measures of central tendency are mean, median, and mode. So you have to tell what actually they measure very briefly. Question 10. Advantages and disadvantages of descriptive statistics. Here you have to just list the advantages and disadvantages briefly. That is, they help in providing means to organize, analyze, and present data, makes interpretation easier, etc. And then you have to add few disadvantages. Mishandling or incomplete analysis is a risk, and another risk is losing the important information. So this way, briefly, you'll write a short note. Question 11, type 1 and type 2 errors. Type 1 error occurs when a true null hypothesis is rejected wrongly, and type 2 error takes place when a false null hypothesis is expected. So you have to mention that under this. Question 12, scatter diagram, which is also known as scatter plot. It is a graphical representation which is used to visualize the relationship between two variables, and you will write briefly about how it is done. Question 13, part correlation, also known as semi-partial correlation. So this is the measure of relationship between two variables while controlling for the influence of a third variable. Discuss that. Then question 14, assumptions underlying regression. Here you have to mention the assumptions about underlying regression. Question 15, standard error. It reflects the variability between sample statistics and population mean, and write briefly about it. Question 16, interactional effect. This is the combined impact of two or more variables which affect the outcome. Because it's a combined effect, that is why we call it interactional effect. Question 17, comparison between Spearman rho and Kendall tau. Both of them are used to measure the association between the variables, but rho computes correlation based on ranks and tau measures the difference in the ordering of the data pair. Question 18, levels of measurement. It refers to the type of data and the scale on which they are measured, and there are different scales: nominal, ordinal, interval, and ratio scale. So you have to mention that. With this, we have completed our last assignment for first year, that is MPC 006 also. Thank you for tuning in. If you have found the content valuable, don't forget to show your support by liking and subscribing. Your engagement helps the channel to grow and reach more students like you. If you need assistance with any specific topic, feel free to drop a comment below. I'll create a video on this topic and share. Your feedback is invaluable in shaping future content. Keep striving for success, and until next time, happy learning. Thank you.